Let's look at an example of a projectile motion. We are examining in this example a horizontal projectile. We have a bomber plane which is flying at a height of 5,000 meters with a horizontal velocity of 185 meters per second. Instead of dropping bombs, good, it is now being used to deliver 8 parcels. It releases a parcel aimed at a target at sea level. For the parcel to reach its target, what is the horizontal distance away from the target should it be released from? So what is our target? Target, pun intended. But what is the horizontal distance away from the target should it be released from? So this is our goal, to find the distance from which the plane should release the package so that it reaches the target safely and people get aid. Let us first draw a diagram of the situation, like we will always do when solving any kind of physics problem. That just makes our lives a lot easier. Let's see. So, modeling the plane as a blob, the plane was moving at an initial velocity of, which was horizontal, of 185 meters per second. And the plane was flying at a height of 5,000 meters above sea level. So sea level is my ground level now. So this height is equal to 5,000 meters. All right, and it drops a parcel, smaller blob. It has dropped a parcel. So remember, the parcel was initially part of the plane because it was inside the plane. So the velocity at which the plane was moving, the parcel was moving in the same velocity when it was released. Okay, so we can just call this big blob to be the target anyway, because they can be assumed to be the same. So the parcel is dropped from the plane, and the trajectory looks like that. Okay, so let's say this is my destination target. Okay, I want to know what this distance is, d. Okay, next we want to note down all of the variables that we have in hand to work with. In doing these problems, what you must realize from the beginning, as we have seen from the general projectile motion, that even though y component of velocity changes due to acceleration in the y direction from gravity, the x component seems to be remaining the same because there is no acceleration in the x direction. So basically, we want to understand the fact that x directional variables are completely independent from y directional variables. Nothing in the y direction can change anything in the x direction. An acceleration in the y direction does not cause you to have an acceleration in the x direction. So what we do when we note down variables in two-dimensional motion, we note down variables in two columns. One column represents everything with x and one column represents everything with y. Let's see how we do that. So we have x column right here, we have y column right here. What are the x variables that we know? We know that the plane was traveling horizontally, and so the parcel was also traveling horizontally at an initial velocity of 185 meters per second. We write that as VIX equal 185 meters per second. Again, I have forgotten, but you shouldn't, to note down your axes. So for me, I'm choosing plus y to be anything going up and plus x to be anything going to the right. All right. So this is a positive velocity since it is going to the right according to my coordinate system. So what else do we know in the x direction? We know that velocity in the x direction doesn't change. So the final x velocity will also be 185 meters per second. Do we know the time it takes to move horizontally? We don't know the time. So Tx, we don't know. What about acceleration? We know since velocity in the x direction always remains the same, acceleration is 0 meters per second squared in the x direction. Okay? Anything else we know? We don't know anything in the x direction. Anything else in the x direction? Let's move on to the y direction. What are the variables? We know that the plane was only traveling horizontally, meaning this velocity was a completely horizontal vector, and so it didn't have any y component. So we can say that VIY was 0 meters per second. Okay. We also know that anything that is released from a height or that is thrown upwards or anything that moves in the y plane or vertical plane feels an acceleration due to gravity. We call that g meters per second squared. So we know acceleration in the y is negative g meters per second squared. Why negative? Because acceleration is downward. I have chosen positive to be going upward. What else? We know the displacement in the y direction that the parcel covers when it's released to when it's hitting the target is 5,000 meters, because this is the vertical distance that the parcel falls. Parcel cannot fall any more than 5,000 meters since it was released from 5,000 meters. So we know that in the y direction the displacement of the parcel is minus 5,000 meters. Why minus? Because the parcel is falling downward, so the displacement covered by the parcel is in the negative y direction. That's why negative. Do we know the time it takes to fall a distance of 5,000 meters? We don't. So the Ty is also unknown. Okay. Now let's ponder a little bit about all these variables that we have noted down. We can see that even though the initial motion of the parcel and the plane was horizontal, the parcel when released from the plane seems to be moving both horizontally and vertically, because when it is released it moves vertically a distance of 5,000 meters to reach its target or to reach ground level if it doesn't reach its target, but it also is covering a horizontal distance because initially the plane was moving in the horizontal direction and the parcel was released with a horizontal velocity. So we see that even though the start can be just in the horizontal direction, it ends up moving in both directions. But it is important to understand that the direction of motion in the x and y are completely independent of each other. One doesn't dictate the other. Okay? So, but we need to solve something. So we know that because these are constant values of acceleration, one is 0 and in the y direction we have negative g, we can use kinematic equations. Okay? And our final goal is to find the displacement in the x direction. So this is our final goal. We want to know the distance it must be released from away from the target. Do we have enough information to get to delta x? Well, we seem to, but as we know that when acceleration is 0, we don't want to use VI's and VF's together in one kinematic equation because that doesn't give me anything new. Do we know enough from y to get to here? Well, not directly. We cannot use y variables to find delta x, because delta x is x variable. So we have to use x quantity or x variable to find delta x. We cannot use y variables to find delta x. But what we can do is we can use 3 of the y variables to find the time. Let's call this time t. This variable, time, is very important in connecting the motion of x and y directions. Time is the only variable that relates x motion of a particle to its y motion, because time is the same whether you drop this marker or anything horizontally like that, or just drop it vertically. So if you can do this experiment at home, take 2 pins which are similar, and then one project it horizontally and one just drop it from the same height. They will reach the ground at the same level. So time actually relates x and y direction. So if you can find time for the y motion, that time you can use for the x motion. Only applies for time. Nothing else in the y variables can you use in the x variables. Okay, so let's go ahead and find time here. So we know vi, a and delta y, we want t. So we can use equation delta x is, use this equation, delta x is vi delta t plus 1/2 a delta t squared. Now replace delta x with just delta y because it is vertical motion. Vi with viy times delta t with just t plus 1/2 a with ay t squared. What is delta y? This is negative 5000. This vi in the y direction is 0, so this term is 0, plus 1/2. What is ay? It is negative g, which is negative 9.8 t squared. So we end up with negative 5000 multiply the 2 equals negative 9.8 t squared. The negatives can go away and the time can be found by first divide 5000 multiplied by 2 by 9.8, take the square root, and then time can be found to be 31.9 seconds. This is the time the parcel takes to move a vertical distance or displacement of 5000 meters downward. Okay, this is also the same time the parcel takes to move the horizontal distance it moves after being released, and we want to find that horizontal distance. So let's now, as we know, Tx is now 31.9 because time is the same for both x and y. We can simply use, since we want delta x, we can simply use that same equation for delta x. So delta x is equal to vi times delta t, vix times delta t plus 1/2 ax delta t squared. Now ax is 0, acceleration in the x direction, so this term goes to 0, and delta x becomes vix was 185, delta t is 31.9, and we have delta x is equal to 5909.6 meters. This is the distance from which, if the parcel is released, it will reach its target. I hope this example has made the concepts of vectors and horizontal projectile motion a lot simpler. Now let's look at an example for an angular projectile. The question reads, one pirate ship fires a cannon at another with a velocity of 79 meters. So velocity 79 meters at an angle of 20 degrees above horizontal, so above the x-axis. Determine how far the rival ship was when it took critical damage. Again, first and foremost, we'll draw out a simple diagram to make our lives easier. Let's say we have two pirate ships, this one here and this one here. Doesn't look like pirate ships, looks like the smiley face emoji if you had two eyes, but let's not go there. And one fires a cannonball at the other. How? So let's say this is the cannonball and it is fired. This is the horizontal. I'm choosing plus x this way, plus y that way, and this is 79 meters per second at an angle of 20 degrees with the horizontal. And the other ship, we are assuming it took critical damage in this scenario. Okay, this is what is given to us, and we want to find how far the rival ship was when it took critical damage. How far will always mean a horizontal displacement. How high would mean a vertical displacement. So we want to know how far the cannonball traveled horizontally to hit the rival ship critically. So we want to know this displacement. The horizontal distance traveled by a projectile is sometimes called the range of the projectile. Also, we know that, as always, gravity makes anything trying to move up come downward. So this is our situation given to us. Now, whenever you see angular vectors, as I've said before, the first thing you want to do is break that vector down into its components. So let's look at this 79 meters per second vector a little closely. So the 79 meters per second vector looks like this, and it makes an angle of 20 degrees with the vertical, and we know that plus y is in the upward direction, plus x is in the rightward direction. By looking at my coordinate axis, I can just see that this velocity vector is moving in the x direction in a positive manner, so the x component would be going this direction, and it's also moving upwards, right? It's tilted up, so the y component would be that. We will call this Vix and this Viy, and using trigonometry we can write down Vix is magnitude of the vector, which is 79, cosine of 20, and Vyy is the magnitude times sine of 20. All right, so this is your starting point for any problem with angular vectors. Now let's note down all of the variables in columns of x and y. What are the variables we know in the x direction? In the x direction, first of all, we know that Vix is 79 cosine 20, and also we know, as always, acceleration in the x direction is 0. Do we know the time? We don't know the time. Do we know anything else? We know that we want to find the range of the projectile, or delta x, and that's about it. We don't know anything else. Now it's time to note down the y variables. We also we know Vfx as well, which is the same because there is no acceleration, but it's just good to note it down. All right, now in the y direction, what do we have? We have in the y direction Viy, which is 79 sine 20. We also know Ay is negative 9.8 meters per second squared, acceleration due to gravity. time is not given to us, it would seem that we don't know much else. So last time in the horizontal projectile example, we used y variables to calculate the time, but it would seem now that we don't have enough information in the y variables as well as the x variables, because again, x variables that you can use, you only know two. You don't know delta x, you don't know time, and also we can't use really vf and vi in the same equation. Then what to do? Well, realize that we are working with vectors. So if the cannonball was fired from a pirate ship, assuming the one firing at the other, they're both of similar power, similar ability, similar size, then the cannonball will have traveled up a certain height, and then from that height fallen down to hit the other pirate ship. If they are of the same height, the two pirate ships, then the cannonball has returned to its original height, which means if you go up a certain height and then come back down the same height, when you add those two displacements together, the total displacement is 0. And so 0 meters, we can now see that we have enough information in the y variables to find t again. So we'll do that using the same equation that we did for horizontal projectile. Delta y is equal to vi delta t plus 1/2 a delta t squared. Let's call it ay and viy. Delta y is 0, viy is 79 sine 20 plus 1/2, a is negative 9.8, I've missed a t here, and this is t squared. So 0 is, you can factor out t because t is in both terms, so take it out, take the lowest factor of t outside, then we are left with 79 sine 20 degree minus 9.8 by 2 is 4.9 times t. So we can see that we have solved that t can be 0, which is nothing but the initial time ti, or t can be 0 equals 79 sine 20 minus 4.9 t. So if I add 4.9 t to both sides, I get 4.9 t equals 79 sine 20. So t is 79 sine 20 over 4.9. Therefore, t is equal to 5.51 seconds. This is the time it takes the cannonball to leave one pirate ship and hit the other. So it's the time it takes to complete the full journey of the cannonball, which is the projectile in this case. And we call this time the time of flight. Okay? So now we have to realize that delta t was not our target. Our main target was delta x. We wanted to know how far apart the ships were. So then we can use the same equation again, delta x, but with the x variables, since we know time now, 5.51. Delta x equals vi delta t plus 1/2 a delta xt, ax delta t squared. Again, ax is 0, so this term goes away. Delta x is what we want to find, and vi is 79 cosine 20 times 5.51, and we are left with a displacement of, or displacement of 409.4 meters. So the ships were 409.4 meters apart. Now, what if I asked you a bonus question? The bonus question goes like this. What is the speed of impact? So at what speed does the cannonball hit the other pirate ship? So if you remember from the general projectile diagram, the trajectory of a general projectile is like this, right? So it goes up at a velocity v at an angle theta, reaches a maximum height where the y component, so we have two components of velocity, one going up and one going to the right in this case, and as it goes up due to acceleration from gravity, this y component of velocity viy keeps decreasing until it goes to 0 here. So vy at maximum height is 0. However, this vix doesn't change at any point in the projectile's motion because there is no acceleration in the x direction. So nothing to make it change. So after the projectile surpasses the maximum height, now gravity is accelerating the projectile downward. So the projectile is moving with gravity, and hence every second it moves down, its velocity component in the y direction increases. So from any point here, we would see that even though x component is the same, velocity keeps increasing as you go down. So at the end point, just before it hits the ground, it will reach its highest velocity, since it will have its highest y component while the x component will remain the same. We want to find the speed of impact. The terminology is important, the speed, not the velocity. Okay, so how do we go about doing that? First of all, we know that we have to first find velocity in the y direction, because we have velocity in the x direction already, and we know speed is the magnitude of the velocity. So as we also know by now that velocity is a vector, and like any other vector, it has two components, one in the x direction, one in the y direction, and we already know its x component. So if we can find the y component, then we can use those two to find the net vector, or the additive vector, or the resultant vector, or the magnitude of the vector. Okay, the magnitude of a velocity vector is its speed. So our target ultimately is to find the magnitude of the final velocity vector, which is the speed. Okay, first though, let's see if we can find vfx. We should be able to, because actually vfy, we should be able to, because we have all of the information required from the y variables. Remember, we cannot use anything in the x variable to calculate vfy. We have to use y variables to find vfy. Okay, let's choose something. So our target is vfy. So I would want an equation which has vfy already on one side of the equation. First equation may work in the kinematic list that we have written down previously, which looks like vfy is equal to viy plus acceleration in the y times delta t. We have everything and we want to find vfy. This is viy is 79 sine 20 plus ay, which is negative 9.8, times delta t, which is the time taken to get to here. So we have found that time of flight to be 5.51 already. Okay, so this gives me the y component of the final velocity, which is negative 27 meters per second. Okay, so we have found vfy. Now we want to find the magnitude of the final velocity vector. How do we do that? We already know that Vfx is equal to Vix. That is, the initial x component has stayed same throughout, and even the final x component is the same as Vix, which we already know. And Vfy we just found, and it is negative, meaning that it is moving in the negative y direction. So this is Vfy in the negative direction. The magnitude is, the speed is this vector right here. Okay, this is my velocity vector, which is just before it hits the ground. Okay, actually the velocity vector looks like this when it hits the ground, like that, so that you can redraw this triangle like so. And remember, any amount of straight lines you draw parallel to this Vfy would be the same. So this Vfy is the same as this Vfy. It doesn't matter at all. So this is my triangle, right angle triangle, and we want to find the magnitude of Vf. How do we do that? Pythagoras. Vf magnitude is equal to square root of Vfx squared plus Vfy squared. So Vfx is nothing but 79 cosine 20. Square it, add it to square of negative 27, and then square root it. We get Vf magnitude to be 79 meters per second. Okay, so this is a coincidence. It doesn't have to be that your final velocity has to match the initial velocity at which the projectile was projected, but our numbers were such that this came out. It is just a coincidence, not a generalization that you can use in all other problems. Okay, so you have to calculate your impact speed when asked to do so. Don't assume that it is equal to the initial velocity. I hope this makes angular projectile a little bit more easier.